Hello, welcome to this video 3-5 on the essentials of calculus. This topic are related rates, and related rates are context problems that are going to involve differentiation, some substitution, and some evaluation. And we kind of have a procedure laid out here for us to kind of interact with these related rate problems. Okay, and so first of all, I want to just talk about these and let you know, and this is highly important, that when you are calculating a related rate, the idea is to find a rate of change with respect to time. Okay, and what you're going to do is always find the derivative of one quantity by using the rate of change with respect to time. All right, so and again, this is just dt. Okay, so whatever that is, whatever we're taking the derivative of, we want to do it with respect to time. Okay, so I'm going to read through these steps. Step 1, draw a figure if necessary and choose variables for all unknowns. We all know that a picture is worth 1,000 words. Okay, so draw a picture if you need to. And also use one if they give it to you. Okay, number 2, write what is given and what is to be found using your variables and dt symbols. This is very, very important. Okay, so right here, step 2, given. What's given? Okay, that's always important, writing those down. Step 3, write an equation relating the variables. Okay, so number 3, this is kind of your linchpin. This is where you connect everything. And part A says if a quantity is changing, it must be represented with a variable letter. Part B, if the quantity is constant, it must be represented with a number. Okay, so we'll go ahead and keep variables if they're changing. If the quantity is changing, if it's constant, we'll plug in a value. C, look for secondary relationships between quantities to reduce the number of variables. Okay, so part C here, this is substitution. If you have a variable, you can go ahead and plug something else in. Step 4, implicitly differentiate both sides with respect to t. Okay, and then 5, substitute number values and solve. Okay, so those are kind of our steps, and we'll go through these. But before we get to some of these problems, it's important to note you do have to know some formulas. Okay, and I'm going to write here, no cold. What that means is it means memorize. You're going to need to memorize these formulas. Some problems are nice. Some problems will give you this information. They'll say note volume of a cone is equal to 1/3 pi r squared h. Okay, but this is stuff that you should memorize. Okay, so again, I recommend flashcards. So if you like using Quizlet, okay, you can use Quizlet, and I believe I have a set already from volume and area from Math 3. Okay, so I'll upload that. You can use that if you're in my class, but you have to memorize these formulas. This is how you relate different variables. Okay, so for this video, the examples that we're gonna go through, I'm just gonna look at steps 4 and steps 5. 1, 2, and 3, we're not going to look at those. Okay, we're just going to focus on steps 4 and 5. These are going to have no context. Okay, so here it says given a equals s squared. Okay, so this is a square. Area is equal to s squared, where the derivative of s with respect to t is equal to 3 and s is equal to 4. They want you to find dA dt. Okay, so step 4, if I have my givens, okay, and I know what I want to find, what we're going to do is implicitly differentiate both sides with respect to t. Okay, so if I do this, dA dt, I just took the derivative of a, right, with respect to t. That's what I mean. That's why t is on the bottom. Is equal to 2 times s times s prime, or the derivative of s. Okay, so derivative of s with respect to t. So that's ds dt. Okay, well, note, right, dA dt I have that. And notice that I have S here. Okay, well, don't they say S is equal to 4? All right, so I'm going to plug in 4 there. And then they also say that ds dt is equal to 3. Okay, so here, this is dA dt, but I just have to do some simple substitution. So 2 times 4 times 3. Okay, and that gives us 8 times 3, which is 24. Okay, so dA dt is 24. 24 what? We don't know. It's some type of units. We don't have context, okay, but units are definitely important in these types of problems. Part B. Given dx dt is equal to -6 and y is equal to 4, xy is equal to 12, find dy dt. Okay, so here's what they want us to find. We're asked to find this. Okay, so what we're going to do is we're going to take our formula that relates all of our information and we're going to implicitly differentiate. Okay, so here's my formula relating everything. Okay, and we're going to implicitly differentiate. Now notice this is x, y, so I'm going to have to use the product rule. So derivative of the first, so that's dx dt, times the second, which is y, plus the derivative of the second, okay? So dy dt times the first, okay, times x. All right, and this is equal to derivative of 12, which is 0. Okay, so what I'm going to do here is I can go ahead and substitute some values in. Now I know that dx dt is -6. Okay, so I can plug that in. I do know that y is equal to 4. Okay, so I can plug that in. I want to find dx dt, okay, and notice that I don't know what x is, okay? So what I'm going to do, I'm going to substitute these values in. I have -6 times 4 plus dy dt, okay, times x, I don't know what that is, equals 0. Okay, so I know that, I'm trying to choose a different color here. I'll put it in green. Okay, so I know that y is equal to 4. So if y is equal to 4, can't I find x by evaluating y equals to 4? I can. Okay, so what I'm going to do here is I'm going to have 4x is equal to 12, which means that x is equal to 3. So I'm just going to plug in 3 here. Okay, and then I'm going to go ahead and I'm going to solve for dy dt. Okay, so -24 plus dy dt times 3 is equal to 0, which tells us that 3 times dy dt is equal to positive 24, which means dy dt is equal to 8. Okay, and there it is. All right, I'm going to end this video. The next 2 examples are context heavy, so we'll be going through this whole problem solving process and looking at those. Okay, so thanks for watching. I'll catch you next time.